फर्स्ट क्वेश्चन है आपकी स्क्रीन पे, कैलकुलेट द मॉलिक्यूलर मास ऑफ ग्लूकोज। मॉलिक्यूलर मास ऑफ ग्लूकोज, तो दैट इज the 6 carbon into atomic mass of carbon कितना होगा 12 into atomic mass of hydrogen और 6 into atomic mass of oxygen, तो oxygen का atomic mass 16, so it is 72 plus 12 plus 96, so it comes out to be 180 U or 180 gram per mole. This is the second question. A compound contains 4.07% hydrogen, 24.27% carbon, 71.65% chlorine. So its molar mass is given 98.96 gram. So what are its empirical and molecular formula? So see, in this case, a compound contains carbon, hydrogen and chlorine. So first of all, you have to calculate empirical formula. Just write the element first. Elements are carbon, hydrogen and chlorine. Then percentage. So percentage of carbon is 24.27. Percentage of hydrogen is 4.07 and chlorine is 71.65. Then atomic mass of carbon is 12, carbon is 1, chlorine is 35.5. Now next part is atomic or molar ratio. So atomic or molar ratio is percentage divided by atomic mass. For hydrogen, take it as 1.08, 35.5, right? So what is the value? 2 point something, 2.02 around. It is 4.04 around. It is again 2.02 around. So simple molar ratio, so that is 2, 4, 2, because divide each one by 2.02, so it is it is 1 to 1, 1 to 1, 1 to 1. So in this way you will get the simple ratio as 1 is to 1. That means empirical formula is CH2Cl. CH2Cl. So this is the empirical formula. Now molar mass is given to you. So from here, what is empirical formula mass? First calculate empirical formula mass. So empirical formula mass is equal to 12 from carbon, 2 from hydrogen and 35.5 from chlorine. So in total it is 49.5. So n factor you can calculate by using molar mass and empirical formula mass. So it comes out to be 98.96 divided by 49.5. So very close to 2. So in this way, molecular formula, that is equal to empirical formula into n factor. So it is CH2Cl into 2, means it is C2H4Cl2. C2H4Cl2. So that is the molecular formula of the compound. Calculate the amount of water produced by the combustion of 16 gram of methane. Say we have methane. Now methane on combustion will give carbon dioxide and water. So obviously carbon of methane is in carbon dioxide. So 1 mole of carbon dioxide is formed, and hydrogens of methane are in water. So 2H2O. So methane gas on combustion with O2 gas will give CO2 gas and water in the form of gas. So balance it first. So okay. Now combustion of methane. So if 1 mole of methane we have, then we will get 2 moles of water. Now 1 mole of methane is 16 gram. 1 mole of methane is 16 gram. And 2 moles of water, 36 gram. 2 into 18. So obviously amount of water produced by combustion of 16 gram of methane, so that is equal to 36 gram. That's it. Okay, next question. Moles of methane are required to produce 22 gram CO2 after combustion. We have methane. Now when combustion takes place, it gives 1 mole of carbon dioxide and 2 moles of water. This is the balanced equation. Methane gas, O2 gas, CO2 gas, H2O. Now see, now there is a relation between moles of methane and mass of carbon dioxide. So just focus on methane and carbon dioxide. 1 mole of methane on combustion produces 1 mole of carbon dioxide. Means to produce 1 mole of carbon dioxide, 1 mole of methane is required. But see, there is weight of carbon dioxide given. So what is, convert this 1 mole of CO2 into its mass. What is molar mass of CO2? 44 gram. Okay, so that means number of moles of methane required to produce 44 gram of CO2 gas, that is equal to 1. So number of moles of methane required to produce 22 gram of CO2 after combustion, that is equal to 1 upon 44 into 22. That means half mole, means 0.5 mole of methane is required to produce 22 gram of CO2 after combustion, right? Now next question. 50 kg of nitrogen gas and 10 kg of hydrogen are mixed to produce ammonia gas. To calculate the amount of ammonia gas formed, we have to first identify the limiting reagent in the production of ammonia in this situation. Okay, so first of all, we have to identify the limiting reagent. So just write the balanced chemical equation first. N2 gas when react with H2 gas to give 2NH3 gas. So just balance it. This is the balanced chemical equation. Now, first step is to determine, you have to identify the limiting reagent. See, to identify the limiting reagent, we will be concerned with reactants only. 1 mole of nitrogen need 3 moles of hydrogen. Now, weights are given. Weight of nitrogen and weight of hydrogen is given to us. So we convert nitrogen and hydrogen moles into mass. So what is the mass of 1 mole of nitrogen? 28 gram. Okay, because that is the molar mass of nitrogen gas. Okay, then what is the molar mass of hydrogen gas? That is 2, and 3 moles are there, so 3 into 2 means total 6 gram. So 28 gram of nitrogen, that needs 6 gram of hydrogen to react completely. Okay, but the same masses are given in kg. So 28 kg of nitrogen will react with 6 kg of hydrogen. So by using this known relation, we can predict, we can identify which one is the limiting reagent. See, first we will write the amount of hydrogen required to react with 28 kg of nitrogen. So that is equal to 6 kg. So now what is the amount of nitrogen we have? 50 kg. So now amount of hydrogen required to react with 50 kg of nitrogen. So for 28 kg, amount required is 6 kg. So for 50 kg, relation is like this. That means 300 over 28 means it is greater than 10. So exact value 300 divided by 28, that is 10.7 kg. means the amount of hydrogen which is required to react completely with 50 kg of nitrogen is 10.7 kg. But how much we have? We have only 10 kg. We have only 10 kg. Required amount is 10.7 kg. That means hydrogen is limiting reagent. That's it. Amount of hydrogen required to react with 50 kg of nitrogen is 10.7 kg, but we have only 10 kg. We have only 10 kg, so H2 is the limiting reagent. So this is the answer of the first question, that identify the limiting reagent in the production of ammonia in this situation. So answer of the first question is that limiting reagent in the production of ammonia is hydrogen. So now this hydrogen, amount of hydrogen decides the product formed as limiting reagent, determines as a limiting reagent determines the amount of product formed so here hydrogen decides the amount of ammonia produced. So step 2, to calculate the amount of ammonia produced. See, again write the balanced chemical equation, N2 gas plus 3H2 gas to 2NH3 gas. This is the balanced chemical equation. Just focus on hydrogen only, because hydrogen is the limiting reagent. So 3 moles of hydrogen will produce 2 moles of ammonia on reacting with nitrogen. So convert them into mass. 3 moles of hydrogen is equivalent to 6 gram, and 2 moles of ammonia, that is equal to 2 into 14 plus 3, 17, means 34 gram. 3 into 2 gram, so 6. Now we will write in words that amount of ammonia produced by amount of ammonia produced by 6 gram of hydrogen equal to 34 gram. Now amount of, because amount of hydrogen is given in kg, so we convert them first into kg. Amount of ammonia produced by 6 kg of hydrogen, So that is equal to 34 kg. So amount of ammonia produced by what is given 10 kg of hydrogen. So it is 34 over 6 into 10, that is 340 over 6, means it comes out to be 56.67 kg. Okay, got it? It is 56.67 kg. That is the amount of ammonia produced by 10 kg of hydrogen. So you can write complete statement that amount of ammonia produced by mixing 10 kg of hydrogen with nitrogen, that is equal to 56.67 kg. Next question. Very simple question. A solution is prepared by adding 2 gram of a substance A to 18 gram of water. So calculate the mass percent of the solute. Calculate mass percent of substance A, because substance A is solute. So that is equal to mass of A upon mass of solution. It is equal to mass of A divided by mass of solution into 100. So mass of A is 2 and mass of solution is 2 plus 18 into 100, that is 2 over 20 into 100. So it is 10%. Very good. So it is 10%. That's it. Next question. Calculate the molarity of sodium hydroxide in the solution prepared by dissolving its 4 gram in enough water to form 250 ml of the solution. First we write the formula, that molarity M is equal to weight of solute, mass of solute over molar mass of the solute into volume of solution, if it is in ml, to into 1000, right? So we calculate molar mass of solute, is molar mass of sodium hydroxide. It is 23 plus 16 plus 1, means total 40 gram per mole. So weight of solute is 4, molar mass is 40 into 250 into 1000. So it is 10. Yes, beta. It is 4 by 10. That means 0.4 mole per liter. 0.4 mole per liter. The density of 3 molar solution of NaCl, it is given 1.25 gram per ml. So calculate the molality of the solution. Our density of 3 molar solution of NaCl is given to you. Now what is the relation between molarity and molality? Molality equal to molarity into 1000 over 1000 into D minus M into MB, where capital M is molarity of solution, small m is molality of solution, D is density of solution, and MB is molar mass of solute. So molality of solution we have to calculate. Molarity of solution is given 3, density of solution is given 1.25 gram per ml, and molar mass of solute is 23 from NaCl, Na, and 35.5 from Cl. So it is 58.5. So it comes out to be, what is capital M? 3 into 1000 divided by 1000 into 1.25 minus M3 into MB. So MB is 58.5. So it is 1000 over 1250 minus 175.5, 1000 over 1074.5. So it is 2.79 mole per kg.